All right, welcome back. Today, we are cracking open a really important paper in AI that totally changed the game for building super powerful models. And believe it or not, it all boils down to an idea that is just deceptively simple. I'm serious. What if the key to building an AI that's thousands of layers deep wasn't some ridiculously complex new formula, but just reorganizing things a little bit? A bit of digital spring cleaning? Well, that is exactly what we're going to dig into. So to really get what's going on here, let's forget all the code and the math for just a second. I want you to imagine we're building an information superhighway inside an AI's brain. The whole point is to get information from point A to point B as fast and as cleanly as possible. Okay, so here was the big problem. In the world of AI, making a network deeper by adding more and more layers, well, that should make it smarter. It's like adding more cities for our information to pass through and get processed. But in reality, it just created a huge mess. See, when that information has to travel through hundreds of these layers, it starts to get weaker, a little distorted. It's kind of like that game of telephone, right? Where the message you start with is completely different by the time it gets to the end. For an AI, this is a massive problem. The experts call it the vanishing gradient problem. What it really means is that the instructions for how the AI is supposed to learn just get fainter and fainter until they basically disappear. It's a total gridlock on our information highway, and the AI's ability to learn just grinds to a halt. So how do you solve a citywide traffic jam? Well, you build a highway, right? An express route. And that's pretty much what the original residual networks, or ResNets, did. They came up with this brilliant idea that changed everything. They created something called a skip connection. It's this amazing shortcut. Think of it like an express lane that lets the original clean information skip right over a few of those complicated city blocks, those layers, and then merge back in further down the road. This was our first information superhighway, and it was a total game changer, letting AI get way deeper. But here's the thing, even this brand new highway, it wasn't quite perfect. It still had some, let's say, unnecessary obstructions. A few weird stop signs, maybe some toll booths slowing things down. The researchers behind this paper, they had a hunch that these little interruptions were still causing problems. So they decided to figure out exactly what was causing these mini traffic jams on their new highway. And they said it themselves. Their whole mission was to create a perfectly clean path for the information to travel, a highway with zero obstructions, where data could just flow, totally free from the start of the network all the way to the end. So they ran these really clever experiments. They took their highway, that skip connection, and they started deliberately adding different kinds of roadblocks just to see what would happen. And as you can see right here in this table, every single time they added clutter, things got worse. They added tolls that made the signal weaker, traffic lights that could stop it completely, even complex interchanges. And just look at those error rates. Every single time, the AI's mistake percentage just shot way up. This was the proof they needed. The cleaner the highway, the smarter the AI. Okay, so now that they'd proven that any obstruction on the highway was bad news, they came up with this incredibly simple, elegant solution. Instead of trying to deal with the toll booths on the highway, they just moved them. This slide just shows how simple and frankly brilliant this idea was. On the left, you've got the original design. The AI does its work, merges onto the highway, and then it has to pass through this gate, an activation function. That's our toll booth. But look at the new design on the right. They just shuffled the order. The activation gate now happens before all the work. They literally just moved the toll booths off the main highway and put them on the on-ramps instead. So the new flow is just beautiful. First, you get the data ready on the side road, the on-ramp. Then you do all the heavy lifting, all the complex calculations, over there. And finally, you just merge that finished result cleanly onto the main superhighway, which stays totally clear, ready for information to zip to the next stop. Now, this all sounds great in theory, right? A cleaner highway, of course it should work better. But the real test, the big one, was to take this new, tidied up design and just push it to its absolute limit. So here's the billion-dollar question. Could this tiny little change, just reordering the blocks, really be the secret to training an AI with over 1,000 layers? I mean, that was something that was basically impossible before this. And the answer was a massive, resounding yes. I mean, this chart just says it all. The bar on the left, that's the old design. Look how high that error rate is. The AI is really struggling to learn. But look at the right. That's the new, clean highway design. The error rate plummets. It's learning fast. It's learning effectively. They totally cleared the traffic jam. And the final result? Get this. They achieved an error rate of just 4.62% on a really tough image recognition test. For that time, this was an absolutely incredible state-of-the-art result, all from just tidying up a little. So, why are we talking about this? Why does this simple idea matter so much? Because this wasn't just some neat academic finding. This breakthrough had a huge impact on the real world. What these papers really left us with are a few massive takeaways. First, that a perfectly clean path for information is the secret sauce for training these ultra-deep and therefore ultra-smart AIs. It paved the way for the incredibly powerful and accurate models we rely on for everything today, from better photo apps on our phones to analyzing medical scans. But maybe the biggest lesson of all is that sometimes the most revolutionary ideas are actually the simplest ones. It really makes you wonder, doesn't it? If a discovery this huge was just hiding in plain sight, just waiting for someone to rearrange the furniture a little bit, what other incredible secrets are still buried inside the AI we use every single day? Thanks for tuning in.